This is problem 23. It's actually a continuation of problem 22. So we'll review that briefly before we move on to 23. The scenario in 22 is a scatter plot with years of experience horizontally and auto premium monthly price. I'll just say dollars or cost vertically. The broad conclusions from the orange is male, the blue dots are female. The broad conclusions from 22 was negative correlation. We can see broadly that we have a negative correlation because essentially we're sliding downward. That's a, ugh, let me make that nicer. That's a rough, very rough idea for what the midline might be. You know, I'm trying to make a line that about half is above, about half is below. It's a very rough idea, but that clearly is sloping downward. So now we take a look at question 23. What can we say about the relationship between the correlation R and the slope B of the least squares regression line? Okay, so we already know that downward means R is negative. All right, and the R correlations, they always vary between -1 and 1. A -1 would be a perfect scenario where every data point is exactly on the line. Sorry, I can't make my dots the same size. If every data point is exactly on the line, it's a perfect correlation. That would be a -1 because we're going downward. If it was vertically oriented, then, you know, we'd have a +1. So not a big deal, but oh, I'm not going to be able to do it quickly, so I'm not going to bother flipping it upside down. If it was flipped upside down, sloping up, and the lines and the dots were perfectly on the line, again, a +1. Anything else other than perfect match is between -1 and 1. And the only thing you really need to know is that a 0 means it's a giant spherical ball. There's no tendency to be flat, or it's an ellipse. There's no tendency to be vertically oriented or horizontal. Sorry, the vertical and horizontal are symmetric. There's no way to tell if there's any tilt because there isn't. That's a heavy analysis of R just from the basic definition of correlation. Now we've got to think about the other half. The slope. Slope is a different word. The slope B of the least squares line. So this is a slope of a line. Slope of a line is rise over run. That has units, right? This is rise is in terms of dollars and run is in terms of years. So the slope, right? The slope is going to be equal the change in dollars over the change in years. I'll just put T for time, right? It has units, right? It's measured in dollars per year. So the units might be anything, right? Is that something like $5 per year cheaper, right? The if you get a year older, is your average price $5 cheaper? Is it $2 cheaper? Is it 50 cents cheaper? We'd have to run the numbers. We'd have to get, you know, try to do rise over run on this line that we've got, or, you know, more likely the technology would give us exactly the equation. Here, we don't have the technology, but we can see we have a negative slope, right? I can't really see anything else. I could make some very rough algebraic guesses here, right? It looks to me like I go from $90 to $0 in, you know, maybe 25 years. You know, I don't want to make a big deal about that. That's around 100 over around 25. Looks like I lose about $4 a year, right? My slope is what it is using the rise over the run in whatever units they are, right? If this was Canadian dollars and we were looking at months, we'd get a completely different value for B. All we know about the B is that it is negative. This slope is going, this is a graph going downward, so it has a negative slope. Other than that, not much else not much other information. With that long-winded analysis, we can quickly get through the 5 statements to see which ones are true. R and B have the same sign. Yep, absolutely. That is true. A positive correlation means, right? As one goes up, the other goes up. That's the definition of a positive slope. The numbers are different, but the sign is the same. Both R and B always have values between -1 and 1. Well, no, B doesn't, because B can be any units, right? Dollars per year, dollars per month, Canadian dollars per decade, right? All those are different numerical values for slope, change in something over change in something, and so can be greater than 1, less than -1. R is always larger than B. Well, again, B can be anything it wants to be, more or less, or B can be pretty much anything according to what the units are. R is between -1 and 1, so saying R is always larger than B, no. This is just, forget that. Sometimes it is, sometimes it isn't. There's no always here. Fourth, the slope B is always equal to the square of the correlation R. They have brought in something else that might ring a bell with you. It might resonate with something you remember about correlation, but it's not the slope B. Again, the slope B is the number according to the data. It's the regression line. It has the actual slope in those actual units, right? B can't be equal to the square of the correlation. The square of the correlation in this example would be a positive number. And B, the slope of the picture the line is clearly a negative number. This doesn't even make sense. It's not even possible if you have a negative slope. The reason it's here, though, is that this square of the correlation R, it has a name. It's called the variance. And it actually is useful when we know the R squared. Then what we say is we state R squared as a percentage, and then we say we can predict R squared percentage of the variation in the one variable because of the other. Kind of like, if R was 0.7, then we'd know that R squared is 0.49, which, of course, that's 49%. So we could say something like in a some kind of scatter plot where that happens, maybe it's I don't know, family income versus SAT of the students. I think it's general knowledge that the richer the family, the higher the SAT score on average. There's always exceptions. So let's pretend it was that. We could say something like 49% of the variation in the SAT scores can be explained by the family income, right? The family income explains 49% of the variation. Not explains, sorry, wrong word. Predicts 49% of the variation of the SAT. Just wanted to divert into that topic because it is close to scatter plots. It's something that one can say when you've got the R value, which comes from a scatter plot. And B is always larger than R is just as nonsensical as R is always larger than B, right? B might be a very, very small number in terms of value, right? This I could measure it in decades of experience. Sorry, I could measure it in days of experience, right? You would not get your premiums down much every day, right? $4 a year. That's about a penny a day. That's a very, very small 0.01 as a slope. Well, that's, again, B just depends on the units that you're looking at. The R squared comes from the physical shape of those dots. The shape of those dots doesn't change if I change my years of experience to days of experience, right? I just change my 0 to 20 to 0 to 7,300, and nothing else changes in the picture. The shape determines the R. The actual units of the axes determine the B. So these have no predictable relationship except same sign. There you go. There's a lot to it, but when you boil it down to just looking at it and knowing, oh, they're both negative, that's about it. Everything else depends on the units. And there it is.